Today we'll be discussing about Darrow-Yannet diagram, which explains about change in volume and osmolarity in response to conditions of dehydration and overhydration. We all know kids like candies, and whenever they see them, they run towards them. Consider kids to be water and candies to be solutes or osmotically active substances. Two kids and two candies, and each having one candy in intracellular fluid and also extracellular fluid. Until they are having one candy each, there is no problem, they will be satisfied. If at all, if the chocolate is missing from the compartment, the kids will run towards the compartment which is having more chocolates or candies. We already know total body water is divided into intracellular and extracellular fluids, and intracellular fluid is almost 2/3 and extracellular fluid is 1/3 of total body water. Consider volume on x-axis and osmolarity on y-axis. Suppose one kid and one candy is removed from extracellular compartment. There will be no movement in any other compartment because everyone is having one candy. So they are all happy. Now there won't be any movement. There is no change in osmolarity because chocolates are equally distributed, and now only the change will be in the volume. Volume will be decreased in the extracellular fluid. Remember, only free candies will be contributing to osmolarity. So there are no free candies, no change in osmolarity. Only the volume has been decreased because water is removed from ECF. Next, two kids are removed from the extracellular fluid or one compartment. Two candies are left free. Now see that there are more candies in extracellular fluid. One kid from ICF goes to ECF because there are more candies. Now he will get a chance of two candies rather than one. So he will move to the ECF. Now what are the changes? In the ICF, you have one kid and two chocolates. In the ECF, you have one kid and two chocolates. That means the chocolate number is more, which is contributing to increase in osmolarity. So there will be increase in the osmolarity. At the same time, only one kid in each compartment, so volume is decreased. So decreased volume and increased osmolarity. Next scenario, two candies will be removed from the ECF. So now you have two kids free in the ECF, and there are two candies and two kids in the ICF. Two kids are not having candy, so they run towards ICF for candies. So what are the changes in ICF? Volume will be increased because kids are moving towards ICF, that is water is moving, and osmolarity will be decreased. Okay, in the same way in ECF, volume will be decreased because kids have moved from that compartment, and osmolarity will be decreased because there are no candies. So this is about dehydration, isotonic, hypertonic and hypotonic. From this we have learned that when there is isotonic dehydration, there will be loss of water and osmotically active substances from the ECF. Then ECF volume will be decreased, but there is no change in ICF volume, and there won't be any change in osmolarity. This is seen during dehydration caused due to vomiting or burns or because of hemorrhage. Next is hypertonic dehydration. In this, volume of both the compartments will be decreased and osmolarity of both will be increased. It is seen in sweating, diabetes insipidus, diabetes mellitus and chronic alcoholism. And the last one is hypotonic dehydration. What is happening here? Volume of ECF is decreased, whereas volume of ICF is increased. The tonicity is decreased in both the compartments. It is seen in conditions of adrenocortical insufficiency.